Hello everyone! In this video, we're going to solve an exercise related to transient voltage in linear circuits. And for this, I'm bringing this exercise. The exercise says that for this circuit, the voltage of the battery is 10 volts. The resistance of the resistor is 1 kilo ohms. And the capacitance of the capacitor is 1 microfarad. If at t equal to 0, the switch is closed and the capacitor completely discharged, how long will it take for the capacitor voltage to reach 6.3 volts? Okay, my friends, this is the question. Let's go to the solution. At t greater than 0, the circuit can be written in the frequency domain as this. If there is no charge in the capacitor at t equal to 0, then we can say that V over S is equal to I of S times R plus 1 over SC. Okay? Taking the lowest common denominator, we get that V over S is equal to I of S RC plus 1 divided by SC. Consequently, I of S is equal to C V divided by 1 plus S RC. And if we divide the numerator and the denominator by RC, we get I of S equal to V over R 1 over S plus 1 over RC. Okay? This is the transfer function that correlates the voltage and the current in the frequency domain. Now, what we wish to do is to take the inverse transform of the current. We're going to use the property This is the property that we're going to use, and the current is therefore okay. This is this current here in the time domain. But we don't want the current. We want the capacitor voltage. And how do we get it? We're going to use the expression that we're going to write on the board. Let me erase it here to get some room. The capacitor voltage will be one over C times the integral of I of t dt. We substitute the expression that we found for I of t. Okay? And if we integrate this, we get okay? And if at t equal to 0, the capacitor is completely discharged, Vc of t equal to 0 is 0 volts. Then we find that K is equal to V. K is equal to V. With this data, we can say that okay, this is the capacitor voltage for all t greater than 0. Now, if we substitute these values here, that the exercise provided, we find that Vc is equal to 10 times 1 minus E raised to the power of minus 1000 t. Okay? And we wish Vc equal to 6.3 volts. This is what we wish. Then we substitute this here. 6.3 is equal to 10 1 minus E raised to minus 1000 t. Okay? And then we find that 0.63 equal to 1 minus t. If we continue, we find that E minus 1000 t is equal to 0.37. If we take the natural logarithm at both sides, we get and then we ultimately find that and the last result will be that T is approximately equal to 1 milliseconds. Okay? This is the time that it takes for the capacitor voltage to reach 6.3 volts. The capacitor voltage it takes 1 millisecond for the capacitor voltage to reach 6.3 volts. Okay? This is the response of the exercise. Okay, my friends, this is the video. I hope you guys enjoyed it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!